What's going on, folks? All right, so welcome to science class today. And guess what we're doing today? We are covering math today. Now, I know you guys are like, oh man, I hate math. Or some of you guys are like, sweet, I love math. Here's the deal. I really think that it's important that you guys are good at this math stuff. And one of the things I was talking to Miss Agbanlog about, your math teacher, about was she showed. Did she show you guys like the quadratic equation? Did she show you that? All right. Do you guys know where that comes from? Not really. No. Okay. All right. What is one of my biggest pet peeves? What can I not? I can't stand it when people do this. Do you guys know? Pull equations out of my hat and say, here, take this equation. And that's kind of what we're doing to you, aren't we? We're kind of just saying, all right, look at this equation. It's really big. It says negative b plus or minus square root of b squared minus 4ac all over 2a. And then you guys are like, where did that come from? Why did you use that? Where is this coming from? All right. And I'll tell you why my reasoning, what my reasoning behind it is. The reason why I'm going to be talking to you about math today is not because I want to punish you more with more math. It's because I want to help you. Because I want you to enjoy it. And I want you to see the relevance of it. And so I figure maybe what I can do as a teacher to help my students is to help them out with their math class and see how it relates to science. And to do that, I need to I want to show you guys the quadratic equation because I want to show you how it's used in the real world. I think that that's going to be really fun. It's going to kind of make your math relevant. All right? Now, I might not make you like math. I admit, I might not make you like math, but at least I will hopefully give you reason to seeing why you would use this stuff. And I'll admit to you as well. I'm going to solve a few problems today. I'm going to make sure that we know how to. I'm going to solve things that you guys supposedly already know. Okay? You guys have seen Complete the Square. Have you seen Complete the Square? Yes. Okay. Do you know why we do Complete the Square? I'm trying to get an idea of what's going on with you guys. All right. What do you do with Complete the Square? Do you guys remember? Turn the equation perfect square, find C. Yeah, all right. So, you've seen Complete the Square, and then you've seen quadratic equation. You don't even really know where it comes from. It's kind of still magic. Why don't I take the time in this lecture and maybe a lecture on Thursday to kind of calm your nerves about it? You know what I mean? And here's the thing. I'm gonna assign homework in this class. It's gonna be math homework. I've only assigned 9 problems, and I'm giving you like a week to do it. All right? And it's 9 not so bad problems. So my job is not to make your life harder, but to really help you out. All right? I'm helping you with your math. So consider today as kind of a tutoring day. But here's the problem is my laptop, the one I used to write things on, and it would be really helpful in this scenario to do math, it's not connecting to the internet. So I'm going to have to teach you math on my desktop, and that's going to be a lot tougher. I'm going to have to think about how I'm going to do it. And so why don't I just try doing it here? All right, let's see. So I gave you a math homework. See, the problem is, it's not that I can't connect to the internet. It's that the computer that I need that has the pen capabilities I don't have access to. So here's the homework. And why don't we do a new file, and we'll call it the introduction. I'm going to teach you through a Google Doc. How's that? In fact, we'll do an untitled document. We'll share this document. We'll call this 8th grade science math introduction. We'll call this content. Got it? And I'm going to change this, make it so that anyone with a link, you guys can actually edit this document while we're typing it together, and we'll work on this together. But don't mess with me on this. Don't start messing up my document as I'm typing it up to you. Sound fair? So jump over to the document, or just watch your computer screen, because it's all going to be in the same place. Got it? All right. So you guys can edit it, but I wouldn't edit it right now. Just let me edit it. Let me talk through this stuff. But anyway, why don't we try this? X minus 5 squared. Do you guys know how to deal with that? You know what? I'm going to do this. Insert equation x minus 5 squared. Oop, not at, squared. Do you guys know how to deal with that? And we'll make this problem number, we'll just give it a bullet number. How's that? X minus 5 squared. Easy. How do you do it? That's, let's insert a new equation. X squared minus 25. Wait. X squared minus 25. Is that how you do it? X squared minus 25. Hey, x minus 5 squared is x squared minus 25. Jenna says yes. Lucas says no. Vernon says no. Everyone says no, actually. And you're absolutely right. And if you do that, I'm going to boot you in the head. You see this boot right here. It is going to be in your forehead because you are absolutely right. X minus 5 squared is really x minus 5 times x minus 5. Are we cool with that? You guys get it? It's x minus 5 times x minus 5, right? And then for that, you guys remember how to do that? You know how to multiply two, what they're called, binomials, because they got two terms each? Is this thing called FOIL. Stands for first, outer, inner, last. All right? So, FOIL, you multiply the first times the first, and you get x squared, and you have the outers, which is minus 5x, and you got the inners, which is another minus 5x, and you got the last, which is negative 5 times negative 5 is positive 25, so you got that. And then, like Victoria is saying, you kind of do an x squared. Let's throw that over there. X squared minus 10x plus 25. And that is absolutely correct. And apparently the anonymous penguin is correct as well. And Nicholas Nakaoka is kind of going up and down and messing with my head. All right, and the penguin is Vernon. Very good, Vernon the penguin. Are we cool with this? Is this kind of like a warm-up to you? All right. All right. Then I'll tell you what, why don't we do another one? X, new equation. Here, I'm just going to do this. Do one of these, pull one of these, and then do this. I apologize if it's going slow. I want you to, oops. Plus 8. What's wrong? Reload this page. Sorry, something got messed up. Anyway. Let me reshare that document with you guys. Alright. Okay, so plus 8. Now here's what I want you to do. Why don't you guys in the chat bar or in the document at the bottom write in your answer. Tell me what you guys think this thing is going to be. And while you guys are doing that, why don't I just kind of copy and paste a few more? All right, so let's do plus 11. And over here will be minus 15. And over here will be minus 7. All right, good. So it looks to me like Victoria's already got it. Vernon's already got it. It's x squared plus 16 plus 64. You guys got it? Yes, exactly, Sophia. That's kind of how you do it. That's exactly what we're doing here. Is everyone on board with what I'm doing? Do you guys understand how he got that? Do I need to explain how he got x squared plus 16x plus 64? Okay, good. I want to make sure. Are we cool with this? Is this like, all right, I have a question for you. At this point, is this math that you like? Is this math that like Victoria told me, you won't get me to like math. Well, at least is this math that you are cool with? Are we cool with this stuff? Yeah, all right. But this isn't the hard stuff, right? I'm just trying to get an idea of where you're from, because I'm not your math teacher either. By the way, just to let you know, there's a strong possibility that I will be your math teacher next year in 9th grade. I'm going to teach you math. I'm actually really good at teaching math, too. So anyway, all right, I'm just wondering if this is like blow your mind stuff, or is this not bad? All right. Oh, no. Mr. Loving is still a math teacher. He's still a great math teacher. In fact, he's going to start teaching calculus. But all right, anyway, you're absolutely right, Vernon. I'm going to copy and paste your answer straight into there if that's all right with you. X squared, blah, blah, blah. And then over here, I'm just going to put x squared, x caret 2 minus 30x plus 225. And then the last one goes to x squared minus 14x plus 49. We cool? All right. And you've seen this. I'm sorry, Anonymous Hyena. I'm messing with your text. There. You can, yeah, exactly. There we go. Good job. Okay. All right. So, here's the question. I thought you were an anonymous penguin, dude. Why are you a hyena now? All right. Anyway, stop typing. All right, cool. So we're cool with this, right? We're good with this. This is stuff that I'm fine with. I am happy with this. All right. Here's the thing I want to do. Is I'm going to highlight some stuff. I'm going to highlight that. I'm going to highlight that. I want to highlight it. There we go. Why can't I highlight that? Highlight it. Oh, that's junk. All right. Fine. I won't be able to highlight it. I want you to take a look at that 8, this 16, and this 64. Is there a way that we can relate those three numbers? The 8, the 16, and the 64. They're multiples of each other, that's true. I agree with that. In fact, how is 8 related to 16? In the same way, how is 11 related to 22? (11 times 2), good. How is negative 30 related to negative 15? Times 2, I agree. How is negative 14 related to negative 7? Times 2. Yes, do you see the pattern here? Do you see that this number right here is really this number times 2, right? That makes sense. I'm looking at that, and it's right there. It's right in front of me, obviously, duh, right? Or Or maybe, yes, Jordan, I'll work on that. But, or what about this possibility? What about this possibility? That number, if I start with that number, in order to get to this number, I just divide by 2. Yes, obviously. Yes, of course, right? Okay. So we'll write that down. If given the middle number and you want the, I don't know, x minus, I don't know, a squared, the a in what? Just divide by 2. You guys see what I mean here? If there's, in this trinomial, because it's called a trinomial because there's 3 parts to it. In this trinomial, if I'm given the middle number, like negative 14, and I want to figure out what this number is, the x minus a, I want to figure out what the a in x minus a is, that number that's supposed to go there, I just take that number, the middle number that is, and divide it by 2. Are we cool? Yes, you good? All right, cool, cool. And that's not even hard. So here's my other question. How do I get from 8 to 64? And I want you to figure out a rule for that and then think of, well, how do you get from 11 to 121? And I feel like you guys already know this game already. Or what about negative 7 to positive 49? How do you get from there to there? There we go. It's squared. You're multiplying it by itself, right? It's that number that you're squaring. You're taking it and you're multiplying it by itself. Are we cool with that? Negative 15 squared is 225. Positive 225. I have a question. Will this last number ever be negative? In this game that we're playing, in this specific game that we're playing? No, it will never be negative because you're just going to add some number to it. It's going to be this plus number, and it's got to be a positive because if you square something, it will always be positive. If it starts off negative and you squared it, it will be a positive number. If it starts off positive and you square it, it will still be a positive number. Is that right? We're cool with that? All right, so let me write that. Okay. Once you have a, you can square it to get the last number. Do you guys understand what I'm writing here? I'm just taking notes. I'm taking notes based off of the observations that you and I are making. Are we cool? So if we start off, so what we've concluded, that we've come to 2 conclusions. I'll number them. We've come to 2 conclusions. If you start off with this middle number right here, in order to get this number over here, you just divide by 2, right? And then if you have this number over here, in order to get that number at the very end, you just square it, right? All right, now let me ask you. Okay, I'm going to ask you again. Is this the hard stuff? Tell me when it's starting to get hard, okay? Is this the hard stuff? It's not. Okay, wait. Sorry, Victor, you kind of messed up our who's that fox? Some fox did that. All right. No, it's not really. No, not really. It's not that bad. All right. You guys want to know a secret? Do you want to know something, a secret? The secret is you just described the process of completing the square. Completing the square is you take a number, you divide it by 2, and then you square it. That's what you add. This is completing the square. Or at least the whole point of completing the square is so that we can have this perfect square to factor down. This is the hard stuff. And it's not that bad. Let me kind of show you what I'm talking about, all right? In Complete the Square, you're going to be given some kind of problem like this. Or let me tell you the beginnings of Complete the Square, all right? What if I had x squared minus 14x plus, and I put a blank. And you don't know what that blank is, right? And then we'll say, well, let me see. Okay. See this number right here? I want to figure out I want to plug in for the blank. And the way I can figure out what should go in that blank is I will look at this number right here. Okay? And I want to turn this into a perfect square. And what I mean by that is I want to make this into a x minus, or x plus or minus, I'm not sure. But x minus blank squared. I want this top line and this bottom line to be the same. What does this number, goes in here right now? What goes in this part where my cursor is? Do you guys see where my cursor is? A 7. How did you get a 7? How did you figure that out? Exactly, you divided by 2. That was the first rule that we came up. We took the b, the negative 14, we divided by 2. That's where we got the negative 7. Booyah! Okay? Okay, fine. You guys think you're so smart? What should the top blank be? Anonymous Fox says, go for it, Anonymous Fox. Put your cursor right in the right spot and then put the answer in there. Exactly. 49. There we go, my friends. That is the basis of completing the square. Because these two things are the same thing. These two equations right here are the same equation. If you don't believe me, write this down on a piece of paper. I dare you, write this down on a piece of paper. X minus 7 squared, and figure it out. Write it down. X minus 7, put a parenthesis around it, and square it. Multiply it by itself. You'll go with, it will look like this. It will go x minus 7 times x minus 7. Then you'll have an x squared. Then you'll have a minus 7x. You'll have a minus 7x. And you'll have a plus 49. And then you'll combine those two in the middle, and you'll have an x squared minus 14x plus 49. Look, they are the same thing. You see what I mean? Like this right here, x minus 7, is the same thing as that. Let me show you how to use this stuff. Now that you're armed and dangerous with this awesome thing called Complete the Square, okay, let me show you how we use this in math and in science, specifically in science. And I want to show you how we use this in science, but before I show you, I got to make sure you know how to use this. Okay? Let's try something like this. Write this problem down. Write it on a piece of paper. Don't just watch me do it, okay? Take out, I want you to take out a piece of paper and write this down. And don't just do this. Don't do this. Okay, Mr. Dalday, I'm writing it down. Yeah, and then just like you're on your phone and you're just like, okay, Mr. Dalday, I'm writing it down. Miley Cyrus did what? No. Take out a piece of paper, put your phone down, write it down. I'm looking at you. You know who I'm talking to. You know I'm talking about you. Write it down. All right, write this down for me. X squared. You know what? I'm just going to do it in an equation. Let's see. Insert equation. Let's do this. X squared minus 6x plus 9 equals 0. You guys got it? You can write it down anywhere. You can write it down on a napkin. You can write it down on a, I don't care. Just write it down. All right? You know what I'm going to do is I'm going to put this in a table. All right. So here's what I'm going to do. No, don't write it on my document. Come on, Hyena. But here, I'll let you write over here. This is the initial problem. All right. Let's see, insert row above. This is where teacher writes. And this is where students. All right. What I mean by right up there is I will write, no, hey, I'm going to write down the problem. You guys will write notes on what I do. How's that? For those of you who want to write on the document, you can write notes, but I want you to write on a piece of paper too. Okay. What I'm going to do is step 1, and I want you to type this out as I tell you. Ready? I'm going to put an odd space inside of the thing. That's all I'm going to do. I'm not going to change the problem at all. I'm just going to do space, 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 plus 9 equals 0. Okay? So, in your notes, write down what I did. Why do I need all the space? Okay. I put a bunch of space in between the negative 6x and the number 9. The question is why? And my answer is because I'm going to do a trick and I want to have the space to do so. Is that a sufficient answer for you? Are you happy with that? Because I'm going to do a trick and I want to have the space to do so. Sound fair? All right. So, I know that you know the answer. And Victoria, I'll tell you what. Victoria, I have a feeling that you're already looking at this and be like, I know how to answer this without using complete the square. And my point is, and I'll tell you what the point of complete the square is in just a second. And I know that you know the answer. But let me get to the, I'm starting off with the baby problems, and I'm going to get to the hard stuff. All right, give me a second. Okay. Okay, you ready? Now, what's the trick? The trick is this. I'm going to play that same trick that I did. This negative 6 is my middle number. Okay? What if I want to turn it into something that looks like this? X minus blank. Okay. X minus blank squared. What number should go there? A 3. Exactly. Not a 3x, just a 3. How did I get that? Well, I took this number over here and I divided it by 2. And then what number should go here? Plus what? 9, right? Right? That's what we did. We took the negative 3, we squared it, and it's plus 9. Now, you can't just go around adding 9. That's not fair. You can't just say, oh, I'm going to add 9. You know what I mean? Darn, it would sure be nice if there was a plus 9 out here, so I'm just going to add it. Plus 9. There we go. Deal with it. You can't do that. So I'm going to have to do a minus 9 as well. And all that does is it kind of makes it a plus 9 and a minus 9. We cool? All right. Now, See these first three terms? These ones right here, do you guys see that? Those first three terms? Those are the same as this stuff, what I have written underneath it. Now, I got to deal with the stuff that's not those first three terms, like the -9 and the +9, but we actually know what that is. That's 0. So look, my friends, we've just completed the square. That's all we did. We did it. We finished. We're done. Complete the square. You asked me to complete the square. Booyah, I did it. Does that make sense? All right, I'll tell you what. I have 10 minutes left. Why don't I solve one problem for you? I'm going to do one more in the 10 minutes that I have. And then what I'm going to do is, on Thursday, I'm going to show you how this relates to quadratic equation. And where it comes from. So it's not magic for you. All right? Let's do another one. This is kind of fun. Let's do it. All right. So let me just kind of delete this stuff over here. But now here's the thing I want to ask you, because at the beginning of the of the course, I asked you, do you know how to complete the square? And you said, yes, I do. Right? You take that number, you divide it by 2, and you square it. And I asked you, do you understand why you complete the square, or why you do those steps? Why do you take this number, divide it by 2, and then square it? Why do you do that? And most of you weren't able to answer me. Most of you said, I don't know. I just do. Well, if you look up here, this is why we do it. Because we want to turn something, when we're given something like this, we want to turn it into something like this and this. And in order to do that, if we only have this number, the -30, we take that -30, divide it by 2, then square it, and booyah, we are done, my friends. And someone's asking, can we convert something into a quadratic equation? Let me get to quadratic equation on Thursday. Because I'll be honest with you, I usually cover this lecture. This is what I'm teaching. This is what I taught my Algebra 1B students like 3 weeks ago. And I spent like 4 weeks on just this, completing the square. We get deep into it, you know? I'm not saying this is easy stuff, you know? So what I'm doing is I'm actually taking this and I'm shrinking it down for you. But the reason why I'm shrinking it down is because I want you guys to see, not necessarily know the quadratic equation. I don't want you guys just memorize the quadratic equation. I hate when people pull it out of their butts and say, memorize this, you know? And I'm not saying Ms. Agmanlog did you a disservice by making you do that. I'll be honest with you, the proof for the quadratic equation on Thursday that you're going to get is going to be a little bit tough. It's going to be tough. And I'll walk you through it the best I can. All right? Let me show you one more problem. Okay? I'm going to do a hard problem. This is the hard version of complete the square. Let's do it like this. Actually, you know what? We'll do this one. X squared plus 8x minus 1 equals 0. Oops. X squared plus 8x minus 1 equals 0. This is the initial problem. I want you folks to write down all of the steps that I took, okay? Fair enough? All right. Now what I'm going to do is I'm going to take the same problem and I'm going to put a bunch of big spaces over here. All right? And someone's asking, what exactly is it we're doing to this problem? Why are we doing this? Why are we making this look like this? And my answer to that is so that we can solve it. I'll show you guys just in just a second, okay? Okay. So what did I do there? I added a bunch of space so that I can do a trick. Sound fair? What did I do? I added a bunch of space so I can do a trick. Now, what's the trick? Here's the trick. I want this right here isn't a perfect square. There's some number that should go over here, plus blank. And I wish that number were there. Do you guys know what that blank should be? All right, Sophia's saying take -8. First question is, okay, you're saying take +8 divided by 2. Okay, what is 8 divided by 2? 4, right? And then square it. That blank would be a 16. Do you see that? Yes, it's just that number, you divide it by 2 and you square it. And, ooh, look at this, look at this. See these numbers right here? Those first 3 numbers, that's a perfect square. That, my friends, is this. X plus 4 squared. If you don't believe me, try it. X plus 4, write down X plus 4 squared, and then FOIL that out, and you'll find that it's the same thing. These are the same. So I can replace this thing now with this perfect square, right? But I'll be honest with you, I cheated a little bit, didn't I? No, I'm just worried about the plus 16. Let me get to that -1. I cheated a little bit because I can't just go around adding 16 to any number, to an equation. That's not fair. You can't just go add 16 to one side of an equation. You can add 0, right? Because if I added 0, what would that do? Would that change anything? Okay, Lucas is saying add 16. Let me get to that -1 in just a second. Hold on. It's still there. It's still there. If you're worried about it, I'll put it back. That -1 is still there, but there's something else that goes with that -1. This is what I'm trying to get to. Is that you can add 16, and I like Lucas's suggestion of adding 16 to the other side, and that is totally doable and totally fine. However, I'm going to do this instead. I'm going to subtract 16. So I'm going to add 16 and subtract 16 from the same side. If I add 16 and subtract 16 at the same time, what does that do to my equation? Does that change it? No. No, not really, because all I'm doing is I'm adding 0. Right? If I add 16 and subtract 16. Like, imagine if I did this. I'm going to let you borrow $16. Right after I put the $16 in your hand, here, 3 5s and 1 1. 16 bucks. I turn around, I spin around, and I say, hey, give me $16. And you give me $16. Did I change anything? No, you didn't have anything added or taken. I mean, you had it added, but you had it taken away immediately. So I mean, it didn't really like enrich your life at all. So that's what I'm doing, is I'm not changing anything because I'm adding 16 and I'm subtracting 16, which is totally legal. Now these first three numbers, this 16, the x squared and the 8x, that's included in here, so that -16 is still there. Along with that -1. You guys see what I mean? And that's equal to 0. It's still there. That -1, that -16, those are still there. I can't ignore them. I can't just get rid of them. Sophia, you asked, why am I subtracting it? Do you understand now? Why did I subtract 16? Why is the minus 16 still there? All right, Jenna's asking, why is the minus 16 still there? And my answer is this. The positive 16 is still there as well. The positive 16 is included in this. Here, let me show you. Let's do some side work. X plus 4 squared, parentheses, parentheses, all right, you guys know how to do this. X plus 4, X plus 4, right? New equation, X squared plus 4X plus 4X plus 16. All right, X squared plus 8X plus 16. Okay, this is some side work. I'm just letting you know. I'm reminding you that X plus 4 squared is the same as X squared plus 8X plus 16. This is what we started our class off with today, right? Right? We cool? You understand that? We good with that? So when I see this right here, all right, first of all, let me ask you this. Do you guys agree with me that this line up above is the same exact thing as this line right here? This line up on top is the same as this line over here. They're the same thing. I've got some 16s on the bottom, but don't worry, I added 16 and I subtracted 16, so I didn't really change anything, so they're the same line. This line and that line, they're the same. Guaranteed Barons, no questions, right? Okay. But look, you see these first three numbers? I can represent that by writing it like this, as a perfect square. I can represent those first three numbers, this first trinomial in here, as a perfect square. See that? And I proved it to you right here. Did I deal with this negative 16 and that negative 1? No, not yet. I haven't messed with those yet. But I know that the first three numbers is the same as that. And I still have the negative 16 and negative 1. So, what am I going to do? Well, I'll deal with it. You have the, you know what, I'll just go like this. Is it all right if I just do this? Let's see. You guys like that? Sure, because negative 16 and negative 1, those are just negative 7. We're having a negative 17. We're good with that. Oh, okay, I see that. I understand that. So look, we've successfully changed this equation into this equation. Or no, opposite. We've changed this equation into this new equation. You see that? All right. Now Jenna's going to ask me, now, why would we do that? What's the point in making it look different, but keeping it the same? Is that what you're asking, Jenna? Jenna's saying, why the heck would I do that? Sure, I can do that. I can do this stupid trick that you told me to do, but why? What's the point? Right? All right, let me show you. Let me show you. And I know that I'm over time. I apologize. I'm actually kind of bummed because I got to go somewhere right now. But I really want to show you. I'm going to show you as quickly as I can, and then we'll come back to this on Thursday. How's that? Sound fair? All right. You can solve, because in this method right here, you cannot solve for x. But when it looks like this, you can solve for x. That's the reason. I'll show you how to do it. Not only will I tell you you can do that, I'll show you to do it. How do I solve for x? Well, first get rid of that 17. Minus 17, let's add 17. Cool? Was that magic? No. Was it magic? I see what you did. Got it. Now what? Now I want to get rid of that square. Oops. Now I want to get rid of that square. So what I'm going to do is I'm going to take the square root of both sides. And taking the square root of both sides gets rid of that, but it also gets rid of this. And I'm going to tell you now that you add this weird looking symbol in. It looks like this. And I'll explain to you why we did that. Yes, Jenna, we could have used the quadratic equation. Yes, I agree with you. We could have used the quadratic equation. Let me show you why I didn't do it. I have a very specific reason showing you why. I want to make sure that you understand complete the square. All right? Now, Sophia, I don't have the time to answer that right now, but I will make sure to answer that first thing on Thursday, I promise. Okay? Now, in order to get x all by itself, it's a very simple process. All you simply do is this. You subtract 4 from both sides. And that's my answer. That is a perfectly fine answer. Negative 4 plus or minus the square root of 17. So, let's try this. Negative 4 plus the square root of 17. I want you guys to write this down. Okay, wait. Square root of parentheses 17. How's that? Google, can you do that for me? All right, write this number down. 0.1231056. Got it? That's one of them. The other one is that's the plus. Here's the minus. It's negative 8.1050 or 1231056. Those are our two numbers. Look at those two numbers. Here's what I want to show you. One last thing, and then I'm done because I have to go. I have to run. But I'm going to show you a graphing calculator. And what I'm going to do is I'm going to graph those equations right there. I'm going to graph x squared plus 8x minus 1. Are we cool? X squared plus 8x minus 1. That was the problem we solved. If you don't believe me, take a look. X squared plus 8x minus 1. Are we cool? But I want you to take a look at this. Where does this thing cross the x-axis? See this parabola? This is a parabola. Where does it cross? Negative 8.123, positive 0.123. That's the point. That's what we're doing. Do you see that? And if you have a parabola that looks like this, see this parabola right here? Have you guys seen that shape before? In real life, I'm talking. Have you seen that shape in real life? In roller coasters? No. You've seen it much more common. We don't really have roller coasters in Hawaii, but I promise you see it every day. A bridge, a jump rope? No. You want to know what it is? Okay. I have a ball. Do you see that? You want to know what that shape is? The shape that it plotted out right there? It's a parabola. It's exactly a parabola. Anything that you throw, a basketball, a football, all goes in a parabola. And where are the most important pieces of information of our parabola? What is the most relevant pieces of information? If I'm throwing you a football, what is the most important? Do you care how high it goes? No. What you care about is where it lands, where it's going to end up. You care about where it is. If you're firing a cannonball, right, and you're on the receiving end of the cannonball, if someone's firing a cannon at you, you care about where that thing lands, don't you? Or if you're the one firing the cannonball, you care about where it lands. That's the only most important part. Well, that's what we're doing, my friends, is we're solving for where it lands. That's why we're solving for when it hits this line right here. Because that's when it lands. That's how the connection. I'm just so passionate about this. I'm so excited about this. I can't even contain myself. That's the point. That's why you should learn completing the square. That's why you should learn quadratic equation. Let me show you where the quadratic equation comes from. Because it actually has relevance in your life. Now, you guys are telling me, I know the next question. I've been teaching for many, many years. I know what the next question you guys are going to tell me. You're going to be like, yeah, but Mr. Dulde, I'm not going to be a corporal inside of the Confederate Army. So why should I care about where the cannonball lands? Right? I'm not going to be a professional football player. And even if I were going to be a professional football player, I don't really care about, I don't think they think about the quadratic equation when they throw a football. So why should I even care? I'll answer that for you later. Cliffhanger! Oof! Alright, folks. Talk to you guys later.